Hello and welcome, my fellow math mortals. We're going to go over a few problems of dynamics here on the physics solver. It's a mechanics solver for the T84 calculator program. So without further ado, let's get started. First problem, a 2.5 kilogram block is being pushed with a force of 15 newtons. What is its acceleration? So you probably would want to write down your given, like the force is 15 newtons and the mass is 2.5 kg. And it's looking for A. So we've got like F, M, and A, and I'm just capitalizing it all. Sorry about that. So in dynamics, that's going to be Newton's second law. And if you didn't know that, that's okay, because guess what? It gives you the formula right here, F equals ma. In this case, we're looking for A, so that'd be option 3. And then we want to plug in what we do know. So the F is 15, and then the M is 2.5. Now you do want to be careful with your units. I didn't label any units here. That's probably a big criticism I have of my own program. So just make sure when you finish the problem, you label your units and whatnot. So it's 6 meters per second squared. And the next iteration of the program, I'll probably include units, but your teacher may put not kilograms, but grams and things of that sort to change it up, or meters per hour type of thing. So just keep that in mind. Units can change pretty easily here. So let's go to dynamics again. And then if a force of 45 newtons causes an object to accelerate at 3 meters per second squared, what is the mass of the object? So again, we're going to go to Newton's second law. And we're solving for m, so that's option 2 here. And then the F is 45, in this case 45 newtons. And the A is going to be 3 for 3 meters per second squared. And so the mass is 15 kg, 15 kilograms. Okay, fantastic. We're going to go again to dynamics. And then in this case, a student needs to to apply enough force to accelerate a 1.75 kilogram textbook at 2.5 meters per second squared. What force must they apply? So again, it's a Newton's second law. And then we're trying to solve for the force, that's option 1. And then the mass is 1.75, 100, just as it is. And then the acceleration is that we want is 2.5 meters per second squared. And so the F is 4.375 newtons. Fantastic. Okay. In this case, we want to calculate the weight of a 75 kilogram person on Earth. So that's more dynamics. And that's actually going to be option 2 for weight. And then the given, we're trying to solve for the weight, so that's W, so that's option 1. And the mass is 75 for 75 kg, 75 kilograms. And the G, now the G can vary, For most students, it's going to be 9.81 meters per second squared. Some it might be just 9.8, and if you're in AP Physics at the time of this video, it's typically 10. So, but we're just going to put 9.81 for our specific application right now. And then so the weight is 735.75 newtons. Okay, and then we're going to go to dynamics yet again for this last problem of this 5-problem set. What's the mass of an object that has a weight of 150 newtons on Earth? Okay, and then we're assuming G is 9.81 meters per second squared. So we're going to go to weight, and then we want to solve for mass. And so we're given 150 newtons for the weight, and the G in this case, G meaning acceleration due to gravity, is 9.81. And then your solution is the mass is 15.29 kilograms. So great. So if you like this program, if you want to see more like this, you can subscribe. We have programs usually demonstrated at least once weekly. There was a long break during the break, so forgive me for that. And then also, if you do have comments, any suggestions, I do read these, and I do make improvements to the programs and update them as you guys do comment on those. Okay, so good luck. We're at mcstutoring.com, and good luck in all your math endeavors and your physics endeavors. I'll catch you next time.